If you imagine a super flexible fabric 50 times thinner than a human hair that could be folded indefinitely, after just 49 folds, its height would exceed the distance from Earth to the moon. And if you folded it just 64 times, the stack would extend beyond the boundaries of our solar system. Let's find out why. Every time you fold the sheet, the total thickness doubles. This isn't just adding a single new layer, it doubles the entire thickness. In mathematics, this kind of growth is called a geometric progression. A single micron seems completely insignificant. And early on, the growth is indeed practically unnoticeable. But with every step, the number of layers snowballs. By the sixth fold, the thickness of the sheet is only equal to the thickness of a human hair. At the 11th fold, it becomes as tall as a regular ant. On the 22nd fold, the stack reaches the height of a double-decker bus. By the 33rd fold, the stack almost reaches the peak of Mount Everest. And after 49 folds, its total height will have multiplied by more than 560 trillion. That is high enough to reach the moon, with almost enough left over to make it halfway back. Interesting facts about geometric progression. An American high school student named Brittany Gallivan managed to fold a piece of paper in half exactly 12 times in 2002. She didn't use an A4 sheet. Instead, she took a giant roll of thin toilet paper that was 1,200 meters long and folded it. This record was officially added to Guinness World Records. In 2009, the MythBusters team taped together a sheet of paper larger than a football field inside an airplane hangar. They only managed to fold this enormous sheet 11 times, even while using a heavy road roller and other specialized equipment. In 2011, students at St. Mark's School managed to fold a 16-kilometer-long strip of toilet paper 13 times. However, Guinness officials refused to certify the record because the resulting roll was unstable and had to be held to keep it from falling apart. An ancient legend about the inventor of chess says that the ruler decided to generously reward the creator of the game. The inventor was modest and asked for just a single grain of rice for the first square. He asked for 2 grains for the second square, 4 grains for the third square, and requested that the amount double for every square after that. But the total amount of rice turned out to be so massive that humanity hasn't harvested that much grain from all the fields in the world throughout human history. Damascus swords get their legendary strength from the principle of layer doubling. A blacksmith forges the steel block, folds it in half, and welds it back together with hammer blows. After just 10 folds, the number of layers multiplies by 1,024, making the blade both flexible and incredibly sharp. Nuclear power became possible and efficient only because scientists found an energy-releasing process that grew exponentially. The operation of a nuclear reactor is based on a chain reaction, in which each splitting uranium nucleus causes other nuclei to split. This snowballing process of constant doubling releases massive amounts of heat and powers entire cities. Puff pastry gets its famous airy texture from having a massive number of layers. Bakers fold the rolled-out dough with butter into thirds and repeat this process 5 more times. The number of layers triples each time, turning into a delicate, crispy miracle of 729 layers in the oven. Banks offer compound interest accounts, in which new interest is earned on the entire accumulated balance. These accounts are quite hard to do in your head because they grow exponentially. But there is a simple rule that helps you estimate when your money will double. You just divide 72 by your interest rate. For example, with an interest rate of 8% per year, you divide 72 by 8 and see that your money will double in about 9 years. Modern computers run on the phenomenal power of geometric progression. Their binary system doubles the number of possible combinations with every new bit of information. Just 100 bits of information contain so many combinations that the total is expressed as a 31-digit number. This number is hundreds of billions of times greater than the total number of sand grains on Earth. This is exactly why password length is so critical for security. A supercomputer can crack a 10-character password using simple brute force in just a couple of minutes. But a 14-character password would require 300 years of continuously testing combinations to crack. Complex security keys used by the military or banks are impossible to crack within the lifetime of the universe at our current level of technology. Many living cells reproduce in the simplest and fastest way possible, by dividing in two. This continuous doubling process causes any living colony to grow at a colossal rate. This is exactly why disease outbreaks escalate so quickly. In just 24 hours, a single microscopic bacterium can form a colony of 1 billion through division, turning a minor infection into a massive epidemic. Human hearing perceives headphone volume logarithmically rather than linearly. Music only sounds twice as loud to us when the signal power increases tenfold. Because of this, devices use the decibel scale, in which sound power doubles for every 3 decibels. Almost everything that enters our system, like coffee or medication, is cleared from the body according to a decaying geometric progression. The concentration of these substances in the blood is halved over equal intervals of time, rather than dropping at a linear rate. Alcohol, however, is an exception. It breaks down at a constant rate. With standard folding, it is difficult to manage the thickness of the layers, and the material often tears along the creases. But there is another method, invented by scientist Koryo Miura, when a space mission required a safe way to fold ultra-thin solar panels. His method allows the entire sheet to fold simultaneously, completely eliminating dangerous tension along the creases. This technology is also used in everyday life. For example, when large paper maps need to be easily folded into a compact, pocket-sized format. Help us keep doing this by leaving a like. Your support really matters to us. Every single like can help our tiny project grow.